Most of you will use a geogrid. You all know what the difference is between a biaxial and a uniaxial grid. Biaxial means that you can use that grid in both directions. They're equally strong in both directions. A uniaxial means one direction of strength only, and you can only put that in perpendicular to the wall, and you roll it out at a right angle and roll it out to behind the wall in that direction. So most of us will be using uniaxial project grids on larger projects, biaxial and smaller SRW systems. But here we will be closer to 70% or 0.7H or 0.8H, but we are going to have grids of the same length all the way from the bottom to the top in that project. That grid is interlocked with the front face. It uses the weight of the block. It uses the distortion of the lugs. And mostly it's used on the gravel interlock between the grid and that block. A solid system will have none of that advantage of where you have that gravel interlock. And if you have slight point loading, I've seen it, there's a little space between a block from this corner to this corner because the one below is either this way or this way. And that little space means that that grid has nothing that's grabbing onto that grid because of that space. But the gravel locks that grid to that block. And that's the advantage of a hollow system. We have a much better connection between the grid to the block than a solid system has. The anatomy of it is exactly the same. We have filter fabric separating the gravel base leveling pad from the foundation. We have our impermeable material. We have drainage system and the crushed gravel inside, and the backfill zone compacted to 95 Proctor in lifts of no more than 12 inches, on usually 8 inches if you only have smaller compactors. 12 inches if you have really good material and you have a big drum roller. I have used clays in this zone. It's a nightmare to work with. Anybody use clay in their backfill? It's a nightmare to work with. We had to use sheep's foot vibrators in order to almost knead it like dough in order to get pressure, force the water out of it and get some decency of compaction. Clay is horrible to work with. It expands and contracts with water, never mind freeze-thaw cycling that happens with it. So it's not great to work with. And if you use clay, these grid layers will get longer. They'll be a higher strength grid that we'll have to use because there's less ability to grab onto that grid with the type of gravels that we have. So good gravel, free draining material is always preferred in anything that happens here. All right? As designers, engineers, as contractors, we want to do everything we can to prevent any water from migrating into this zone. This is sort of like a sacred zone. We don't want water in there. Do everything that we can. And I'll show you some projects where we put wick drains or mirror drain along the back side because there was water in the bank. We got it here and dropped it down and put it through. All right? Water from the top. We want to prevent that from coming into this area. Everything we should do, we should protect ourselves from having water in there. Number one reason why walls fail, water. And I'll show you some failures that will be stunning on what water has been able to do with some projects. During construction, water is really important that we manage. All right? I had projects, and what we did, it was a policy that we had to make sure that all backfill material had to be compacted and sloped in the right way away from the face of the wall. That was the way we had to, especially if we knew that we were going to have a rainstorm that night. We had to protect our project, and there's so many damages I've seen while constructing. So you guys as contractor, protect your project during construction. It's worth it. Second reason why walls fail, anybody know? Because us as contractors don't install properly. I've seen grids put the wrong way. I've seen backfill using on-site logs, all kinds of crap that they put into place. We as contractors really need to be sure of ourselves in how we install our projects. Third reason why walls fail is usually because there's an improper design. The grids aren't long enough, the burial's not deep enough, it hasn't passed the global stability zone, all these things. So we have to have those three things focused on when we have a project that's getting taller. Smaller walls, not so critical. But on smaller walls, any of you guys do the Allen Blocks Cornerstone Keystone product, the 80-pound units? Most of you do those, right? The most sensitive area is the last 2-3 rows. And the reason is that we put topsoil in the back of that area, has no structural strength, it gets wet, it freezes, and it rotates the top of the wall. You'll see a lot of failures on the top of the wall. What I used to do, even if the design didn't call for it, I would put a piece of grid in 2 courses down. I would put a piece of grid in. Automatically, that was my insurance policy because I wanted to self-insure. As a contractor, I didn't want to see that failure. That last 2, 3, 4 rows of the wall is the most sensitive area. It's not a big failure, but it just looks crappy when you have that thing starting to rotate over top. And that's because we have no structure behind that, all right? Here's some projects. You can see that we use big equipment for some of this wall, these projects. Remember to make sure that this grid layer is well stretched out, that gravel is all nice and flat. You don't want dips and bumps in that grid, because the strength of that grid changes depending on how much dipping and rising that grid does. So we want a nice flat surface for this grid to be involved in. One of the things that I did is for our engineer is back before digital cameras, I would go to a deposit. Anybody seen those things that we got from drugstore? The little throwaway cameras, the little plastic things that had a date and time on each one of the pictures that you took. Well, I had that for every project, and all the foremans had to take a picture of every grid layer that went into that wall. And all he had to do is take a picture on the side, and it would give me a really close estimate on what the length of that grid was, how well it was put in, and what layer we were on the wall. And the amazing thing was that it was usually used so I could give it to the engineer so he didn't have to come on site as much as he would otherwise. And it would also be a history for us on what we had done in the project. But the foreman, Joe, would say to the other guys, hey, I have to take a picture. And what did that mean? Make it look good, right? The quality assurance that we came up with because we forced those guys to take pictures of every grid layer was really quite neat. So if you guys ever do that and you have multiple crews, not only for your own record, take pictures of your structural installation procedures, but also save them, and your crews will start getting have more pride in what they do. So it was really a neat kind of thing that we did. This company used a tensioner. It's probably a little complicated, but make sure that you backfill from the back of the wall to the tail of the grid. We want pressure going that way, okay? So backfill from behind to the tail so that we keep tensioning our grid in the right direction. Big compactors, keep them away from behind the wall. We can use big plate compactors behind here as well. Smaller equipment can install the product. Remember, it's only about 1,400 pounds, the product, so it can be slung in with a relatively small equipment. Here's some projects. Convex concave curve on a residential project, a negative slope below the wall, a right angle corner with railings on top. This was a gigantic project in this interior of British Columbia. It was about 120, 130,000 square feet of walls. They took years of building. Actually, this is the project that you see on the TV as you're running. But all of this is just mountains. If anybody been to British Columbia, Vancouver, yeah, it's just mountains. We don't have anything flat. We're goats. And it rains, and so we quack like ducks. So we have two things that we have to deal with. But walls, some of our projects on on a regular residential property, we had 3,000-4,000 square feet on a one residential property. That was not uncommon for walls to be on residence, because we were going up sides, and they had to try to flatten that area out in order to get really good usage of their property. And that is going to be something that you'll see more and more of. If you guys are in the wall business or thinking of trying to get into the wall business, it will be the future, and the growth will be amazing, because land is no longer being made. We are going to have to use more and more difficult building sites, and all of these view lots are going up. In Vancouver and the lower mainland, all agricultural land is in a freeze zone. You cannot build, you cannot develop agricultural land anymore. And the reason is we have to feed ourselves, right? So where do we go? We go view lots up the mountainside. You'll see the same thing in some of the residential areas here. You'll see them just start going up hillside. Walls are going to be needed more and more and more. Commercially, big areas, they'll need more parking area, more area for developing. Cities and counties and governments, they're going to expand their roadways. They can no longer slough it off in a V shape. They don't have the land usage for that. They're going to have to go vertical. Walls are going to be needed more and more and more. It's a great industry to be involved in. We can do different textures, a boulder face. This is a gigantic wall, 42 feet tall. This is Iceland. I was in Iceland and Denmark. We have new producers there. And this was their first project in Iceland. And they did a charcoal finish on it to match all the volcanic rubble that's all over Iceland. Anybody been? Iceland is really cool. It's a cool place. It looks like a moonscape in many places. This lichen and mosses and heather growing everywhere. There's gigantic waterfalls and rivers running through the place. It's pretty neat. This is that tall project that I was talking about, 42 feet tall, but a huge negative slope below that. We had burial on this of about 3 to 4 feet of burial on that wall to accommodate that negative slope that was going to be below the wall. Positive connection, and this is less to do with you guys as far as installation on regular residential project. This is more to do with DOT. They require a positive connection, a higher safety factor on the connection between the grid and the face. So this is how we accommodated that. We just run the grid through and out the back side of the unit. And this is, we get 100% coverage except for the lowest course, and the top course would be 50%, but everything else is 100% coverage. But it gives you a sense of what we can do if you really need to get into those big projects.